math class today. And in math class today, we are going to start with this topic, factorization. The topic is what? Is factorization. Factorization, can you say that? Alright, factorization. We are going to start with factorization. Factorization is one of the uses of HCF. In other words, we apply HCF in factorization. Our last topic, HCF, is applied. In this topic now, factorization. Okay, let us start from talking about what is factorization. When we factorize, factorization is a closing a bracket in such a way that when we open that bracket, we get exactly the expression we have factorized. Factorization is closing a bracket in such a way that when we open that bracket, we get the expression we have factorized. Let's have an example. If we have AM plus AN, let's have that number one. AM plus AN, assuming they say factorize. Factorize. AM plus AN. What do we do? First of all, we find the highest common factor of these two expressions. So, the HCF of AM and AN is what? We find the HCF by having AM is equal to A times N.
I'm not saying it very well. I don't see AN and M.
Yes, we are trying to factorize the expression AM plus AN, okay?
Okay.
Yes, we want to factorize the expression there. And we said to factorize the expression, first of all, we'll find HCF. So in our solution, what is the HCF of AM and AN? The HCF is AM gives us what? A times N. Yes. AN gives us what? A times N. Then what is the HCF? This is the HCF. Is it not true? I think HCF of, yes, HCF is what? A. Because HCF is A, we will use that HCF to factorize this expression. And so to factorize AM plus AN, we are going to bring that A outside. Put a bracket, have AM over A plus AN over A. The same HCF we brought up here, the same HCF we are using to divide it inside the bracket. And so we are going to cancel out. Cancel out, they go. Cancel out, we cancel out. Then the factorized expression. Yes.
I don't understand.
Okay, yes, I'm going to make you understand now. Okay, do you understand AM plus AN as expression? Do you understand? Yes, understand AM. Do you understand AM plus AN as expression, as an algebraic expression? If you understand that, yes, you understand. The first thing we did is to find the HCF of the two expressions to be able to factorize it. So the HCF is found by what we have done now. If we divide AN, we are going to get what? A times N, from what we did last week. If we divide AN, we get what? A times N. And so the HCF of the two expressions is what? A. Then bring that A out. I'm putting this because so you don't understand. Bring that A out. Use that A to divide AN. Again, use that A to divide AN. Can you see that? Now, we will divide this because we can cancel A here. Yes?
I'm not seeing the board very well.
Can you see it very well now?
I cannot see the left of the board.
The beginning of the board. The number 1 is what we are
This
seeing.
side.
Good. Is it okay now? Thank you.
Oh, I cannot see it again.
Thank you. Okay, so we can continue by cancelling out A here. Can we continue? Yes. A we cancel A, of course. A we cancel A. What we have as our last expression, we have A bracket N plus N. We have factorized this expression to become A into M plus N. Remember the expression we factorize? Yes. The expression we factorize is what? AM plus AN. So to factorize the expression, first of all, you find HCF, the highest common factor of that expression. We have found the highest common factor of AM and AN. This is where we found the HCF as we have been doing before. Then bring A out, bring HCF out. Use the same HCF to divide the expression. Use the same HCF to divide the expression. After division, the answer you get becomes the last answer. Remember what we said before? That when we factorize expression, when we open the bracket, we get this factorized expression. I hope that is clear. Eh?
Yes.
Very good. I'm going to include number in the next example. Let's have number. You don't understand it, eh? Let's go to this number 2. Now we have, let us have it as 2x plus 4y. I think you are asked to factorize this. Factorization. How do we factorize this? To factorize it means to make a bracket in such a way that when we open that bracket, we will get the same expression we have here. The first thing is what? Find HCF of 2x and 4y. Please, can you do that? I want you to find the highest common factor of 2x and 2y. Find the HCF. When you get the answer, you tell me. Yes, the HCF of 2x and 4y is what? The HCF, not LCM, HCF. What is the HCF? 2x and 4y. 2, you are correct. 2. So that 2 is what you are going to write outside. Write it outside. And then 2x. Use that 2 to divide 2x. Plus 4y. Use that 2 to divide 4y. Whatever you get will be your last answer. And so I will still write 2 here into. We cancel out here, 2 we cancel out. We are left with only x. And so we write that x plus 2 cancel itself is 1. 2 cancel 4 will give us 2. So we have 2y. So the answer becomes 2 into x plus 2y. That becomes the last answer. I hope you understand that.
Yes.
Very good. So you see that if we open this bracket now, what we are going to have is 2 times x, we get back our 2x. 2 times 2y, we get back our 4y. And so this expression has now been factorized. What is the message? Is that understood? So what we conclude now? We can conclude now that factorization is opposite of opening what? Brackets. And so when we open this bracket, we get this expression. When we factorize this, we get this work here. Then number 3. Yes, very good. Thank you very much. Number 3. Let's have number 3 as 3xy minus 9x squared. 3xy minus 9x squared. Hello? Do you understand? Yes, I want to know the problem. Any problem? I can continue with number 3. Number 2. LCM. Find the HCF of 2xy and 9x squared. Find the HCF of 2xy and 9x squared. Please, when you finish, let me know you have finished working. The highest common multiple, the highest common factor of 3xy and 9x squared. What is the answer? What is the HCF?
X.
Okay, are you sure it's x? That is not going to... Okay. Do it very well. Work it very well. Have you written the number? Yes, I'm waiting for you to write it very well. Is that done? 3xy minus 9x squared. First, find their HCF. Find their what? Their HCF, yes. And this is the HCF. We pick up the first one, which is 3xy, and divide them. Use 3 to divide. We are going to get cancel out 3 and have xy. Use x to divide. We are going to get y. Use y to divide y. We are going to get y. We have finished this division now. And so the next thing, we divide 9x squared. Use the smallest prime factor you have to divide. Prime factor you have. The first prime factor here is 9, is 3. 3 divided 9x squared will give us 3x squared. We have only divided 9. 3 divided 3x squared will give us x squared. Then we can use x to divide. X divided x squared will give us x. X divided x will give us 1. We have finished division. And why are we dividing? We are dividing because we are looking for the HCF. Then let us get the HCF. Then the HCF here then is 3xy is equal to 3 times x times y. We're still finding HCF. Then 9x squared is equal to 3 times x times x. Where are we getting this? We're getting it from the division. We got this from this division. And so, what we have here will give us the HCF. Anyone that is the same, we pick it as 1. 3 is one of them. 3 is a common factor, we pick 3. X is here, but x is also here. We will pick it. But 3 is here, no other 3 is here. We will not pick it. Let us pick x. X is here, no other x here. We will not pick it. Y is here, no Y here. We will not pick it. So it's going to be 3 times X is the HCF. The HCF 3 times X is 3X. I hope you understand that. You understand that? Okay. So you see, the HCF of these two expressions, this question is what? 3x. It is that 3x that we are going to use to factorize the expression by saying, bringing that 3x out and opening the brackets. Can we continue? We can continue. When you have brought the HCF out, open the brackets, you write 3xy over 3x. The same HCF we have written outside, the same HCF we are going to use to divide. Minus with a minus 9x squared. We divide by 3x. Close the brackets. Now, whatever you get from this division will be our last answer. What we are going to do, 3x is still the outside, into 3 divided 3, 1. X divided x, 1. We have only y survive. Minus 3 divided itself, 1. 3 divided 9, 3. X squared means x times x. So, but only one x is what we have here. X divided x will give us only one x. So we have 3x. We close our brackets. Then, this is our last answer. We have answer as 3x into y minus 3x as our last answer. That is the factorized expression of this question. We'll factorize it to get this. Is that okay? About factorizing this expression, 3xy minus 9x squared. 3xy minus 9x squared. And what do? We first do what? Find their HCF. This is where we're finding the HCF. Find the HCF by using the smallest number to divide them. 3 divided 3xy will give us xy. X divided xy will give us what? Y. Y will divide y will give us what? 1. And so, we go to the 9x squared. 3 divided 9x squared will give us 3x squared. 3 to divide 3x squared will give us x squared. X divided x squared will give us x. And x divided x will give us 1. 1 shows us we have come to the end of the equation. Do you understand? 3x. The HCF is equal to 3x. And then we are using that 3x to factorize. This is the last answer to the question. Do you understand that?
Yes.
Very good. Who doesn't understand? This side. Okay, you need to understand this side, yeah? Okay. When we find the okay, yes. When we find the HCF, you use that HCF to factorize the expression. And this is how to factorize the expression. Bring the HCF outside, write the numbers inside, and use the HCF to divide each one. And so, yes, we write HCF outside. If you are factorizing, you write HCF outside. Okay? If you are factorizing the expression, you write HCF outside. Use that HCF to divide what you have inside. What? Okay, 3x comes there because when you divide 9 by 3, you have 3. When you divide x squared by x, you have x. So 9x squared divided by 3x will give you 3x. Let me show you what I mean. We have 9 times, are they seeing that? Yeah. 9 times x divided by 3 times x. You can see that what will happen is that 3 will divide itself, 1, divide 9, 3, x will divide itself, 1, divide 1, 1. 3 times 1, right here you say 3. 3 times 1 times x. That's where we got the 3x. So if we use 3x to divide 9x squared, we get 3x as the answer. I hope that is understood. Do you understand that? Yes. Okay. So this. Number 2, yes. Number 1, number 2. Then number 3. Yes, we have 4 questions there as classwork. Just write them down. When you write them down, we will solve. When I solve 1, I will allow you to solve 1. I solve 1, I will allow you to solve 1. So I will solve the first question. Question number 1. Are you listening? We are going to illustrate. We want to find, the question says, find the HCF of the following. Then use the HCF to factorize. So what we have done is written the questions. Number 1 is PQ minus PR. PQ minus PR. If we find the HCF of number 1, it is going to be, we divide PQ. When we divide PQ, P we divide to give us Q. Q we divide to give us 1. We are looking for the HCF first. We come here and divide PR. PR. P we divide to get R. R we divide to get 1. Then, no, the HCF. We find the HCF first. The HCF, yes, the HCF of PQ and PR is equal to what? That one that is the same, which is what? P. I hope you know how it is P. Very good. The HCF for P, Q, and PR is P. Therefore, we use that HCF to factorize. Factorizing now will give us, bring the P outside, write PQ divided by that HCF, which is P. Write minus PR, divide that PR CF, which is P. Then we can cancel out. PQ means P times Q. Therefore, we can cancel out. We have only 2. When P cancels out, we have only I. And so the last answer will be P bracket Q minus I. This is the last answer for number 1. 6P squared. We have 7mn plus 14m squared. And 8k jk minus 4k rest of power 3. The last one is 9ab plus 27abc. Yes, you do the assignment here and let me know the correct answers in our next class.
Number 3.
Number 3, yes.